So let us find the cross product between these two vectors. Let's follow our definition of the cross product. It's the determinant. So as you know, the very first row is fixed. I, j, k. The second row, elements of the first vector, -1, 7, and 4. And the last row are the elements of vector v, 6, 2, -0.5. Well, the way that we define the determinant of a 3 by 3 matrix, we're going to multiply I with the determinant of this little submatrix here, which is -7/2 minus 8 in the direction of x-axis, minus, remember that we have a subtraction, j times the determinant of this 2 by 2 matrix. So we're going to have a half minus 24 times j in the direction of y-axis plus, and here we have k times the determinant of this 2 by 2 submatrix, which is -2 minus 42 in the direction of z-axis. Now let us do the algebra. So here we're going to have -23 divided by 2, I minus, here we have 48, -47 divided by 2, j plus, here we have -44, k. We can represent this vector as, well, -23/2, comma, 47/2, comma, -44. As you can see, the result is a new vector. We're going to see that this vector is perpendicular to both vectors u and the vector v. So let's go to Math 3D, add object, the very first vector. The components of the first vector are -1, 7, and 4. So this is our very first vector, vector u. Let's add another object, the second vector, with components 6, 2, and -0.5. So this is our second vector, vector v. And finally, let us add the third object, which is the cross product between these two vectors with the first component, -23 divided by 2. The second component, 47/2. And the last component, -44. Very well. This is our third vector, which is perpendicular or orthogonal to these two vectors. If you consider the plane passing through these two vectors, the cross product between vector u and vector v is normal or perpendicular to this plane. There you go. Let's present more formulas related to dot product, cross product, and the angle between vectors. I'm going to keep this example and show you that for sure this new vector is perpendicular to vector u and vector v. We can use the dot product and cross product to find the angle between two vectors. The dot product between two vectors can help us to find the angle this way. Cosine theta is equal to u dot v divided by the magnitude of u times the magnitude of v. The sine theta, the angle between two vectors, is equal to the magnitude of u cross v divided by the magnitude of u times the magnitude of v. Here we have some observations. Well, note that cosine of pi over 2 is 0. So if you have two perpendicular vectors, the angle between them is pi over 2. And cosine of pi over 2 is equal to 0. Or two vectors like u and v. When they are perpendicular to each other, the symbol that you're using is perpendicular. When they are perpendicular to each other, the angle between them is pi over 2, and the cosine of pi over 2 is equal to 0. So if you look at the first formula, the cosine of pi over 2, which is equal to the dot product between u and v, divided by, this is just the magnitude, this is just the number, magnitude of u times magnitude of v is equal to 0. What does it tell us? It tells us the numerator of this fraction must be equal to 0. So u dot v is equal to 0. The dot product is 0 if and only if the vectors are perpendicular to each other. So u dot v is 0 if and only if u is perpendicular to v. They are orthogonal to each other. This is an important observation that we have here. Well, okay, let's take a look at this example that we did here. We said that the cross product between vector u and vector v is a new vector perpendicular to each of these vectors. By checking this observation, we can also check to see if it's true or not. U dot u cross v. So u is just -1, 7, and 4 dot u cross v is -23 over 2 and 47 over 2 and -44. Well, the dot product between these two, we get 23 over 2 plus, here we have 329 divided by 2 and minus 176. So let us take the common denominator between these. Here we have, so if we add these two together, we get 352 minus 176. So here we have 352 minus 352 divided by 2, which is 0/2, which is 0. The dot product is equal to 0. So it means that U and U cross V, they are perpendicular to each other. This is vector U, and this is vector U cross V, perpendicular to each other. The angle between them is equal to pi/2. You can also check to see if the dot product between V and U cross V is equal to 0. What's the meaning of that? It means that these two vectors also perpendicular to each other. Let's check to see if we have the same observation here or not. So let's just bring this and show that V is also orthogonal to the cross product between U and V. So our V is 6 to -0.5. So here we get minus 138. And here we have plus. Should I get rid of the denominator? I need the denominator, so let me just multiply this. 94/2. And here we have plus 244/2. So if you add these two denominators, here we get 8, 138, which is 0/2, or just 0. So as you can see, the dot product between V and U cross V is also 0. What's the meaning of that? It means that V and U cross V, they are perpendicular to each other. Let's go over one example to find the angle between two vectors, and also the angle helps us to find the dot product or arriving to other information between two vectors and more. So this example says let the length of A is equal to 4, and the length of B is equal to 6. And the angle between them, and theta, the angle between these two vectors, is equal to pi/3. Pi/3. Question says find the dot product between them. A and B. Okay, to find the dot product between A and B, it's better to use the first formula because it gives us the dot product. So we know that U dot B is equal to cosine of theta times the magnitude of each of these two vectors. Cosine theta times the magnitude of U times the magnitude of B. So in this case, they have two vectors, A and B. So A dot B is equal to cosine of pi/3 times the magnitude of the first vector, 4, the magnitude of the second vector, 6. It is equal to 1/2 times 4 times 6, which is 12. Another example. This example gives us two vectors. Let vector A as components. Let's see. 2, 2, negative 1. And vector B as components. Well, 5, negative 3, and 2. Question says, find the angle between A and B. So to find the angle between A and B, we can use either the first formula or the second formula. Just note that if you want to use the second formula, you have to find the cross product between these two vectors. So of course, it's easier to use the dot product. Since it is easier to use the dot product, we're going to use the formula cosine theta equals to u dot v divided by the magnitude of u times the magnitude of v. Very well. So on the numerator, we have 2 times 5, 10, 2 times negative 3, negative 6, negative 1 times 2, negative 2, divided by the magnitude of the first vector, which is 4 plus 4 plus 1 times the magnitude of the second vector, 25 plus 9 plus 4. So cosine theta is equal to, well, here we have 2 on the numerator divided by square root of 9 times square root of, well, here we have 13, which is 58. I'm sorry, 38. So let us use our calculator to estimate theta. Theta is equal to, or let us do the approximation, inverse cosine of 2 divided by 3 times square root of 38. By using our calculator, theta is approximately 1.46. 1.46, which is approximately 84 degrees. Since we are using our calculator, we use the approximation of inverse cosine of this number, which is approximately 84 degrees. Again, note that we can use the cross product between two vectors, but since we calculate the cross product, we have to calculate the determinant. We prefer to use the dot product. You might be interested in finding the angle between the vector with positive side of x-axis, y-axis, and z-axis. So let us use our formula and try to see if we can come up with some nice angles, direction angles for a vector.